Welcome back to Lecture 3. This is Jason Baker, and our next topic in the lecture is virtualization. Now, before I describe in more detail what virtualization is, the first thing I want you to think about is a stack. And what I think a stack is a combination of infrastructure, operating system, and applications that are required to support a given service. If you think about nearly any application, you have to install that application generally on a physical server. And on that physical server, you install an operating system. And then you install your application to run within that application. All three of these different components comprise a stack. Before the early 2000s, if you were going to deploy a stack, you would need to go out and buy a physical server and you'd install your OS on it and then install your application. And you would only install one operating system on that physical server. There were only one OS per server and life was very simple. And then in the early 2000s, we saw the new commercial solutions from companies like VMware offering us virtualization. And this was really an absolute game changer in the IT marketplace because virtualization allowed us to run multiple stacks, to run multiple operating systems, each with its own set of applications on the same physical server. And that's because what virtualization allows us to do is that virtualization is essentially is essentially software which emulates hardware. So a virtualization is nothing more than a software application which essentially tricks the computer or tricks the application into thinking it's a computer. And that virtual computer can run its own operating system and its own set of applications. This sort of emulation wouldn't have been possible before the early 2000s because our our servers just weren't fast enough. The CPUs weren't fast enough. With we still had memory constraints and disk constraints. But by the early 2000s, we saw fast CPUs, memory was getting cheaper, and the size of hard drives was steadily increasing, and so it became possible for us to run virtualization on a typical system and have it perform well. Now, these emulated systems, these virtual systems that are running on the same physical server are logically partitioned from one another. Each virtual server has its own process space and memory space, its own networking stack. So the applications and the data are effectively fenced off from one another. They are running in separate logical environments. Virtualization solves a lot of problems for us, and it's a foundational technology for cloud computing because most of the computing that we leverage in the cloud are running in virtual servers. We have physical hardware systems in the cloud that are supporting multiple workloads, oftentimes from multiple different customers. But these environments are effectively partitioned from one another because of this virtualization technology. Virtualization, as I mentioned, essentially allows us to take physical hardware systems, to take these stacks and run them and treat them as if they were software. And that makes it really easy for us to maintain virtual servers and makes it easy for us to move virtual servers from one system to another. We can move a virtual system from one physical server to another physical server just as easy as we can move data from one system to another system. Virtualization also allows us to support multi-tenant type of environments. Back in the day, if I worked with multiple customers and each customer would have to have their own physical server. Today, I can support multiple customers running on the same physical server, and each one of those customers has their own virtual environment that's effectively partitioned from other customers. Okay, before we look at some of these virtualization technologies in more detail, there's a couple different definitions that I want you to understand. First, a host machine. A host machine is the actual physical server that is running and supporting multiple virtual machines. With a virtual machine, you still need some sort of physical server, a physical device that is going to run the virtual machine. And that's the host machine. The virtual machine then is that virtualized server. That's that emulated server that's running on the host machine. Sometimes we call a virtual machine an instance, or sometimes I'll use the term a workload. These all mean the same thing. That's an emulated computer system, the virtual machine that's running on the host machine. The host machine has its own operating system, and that's what we call the host OS. And each virtual machine oftentimes has its own operating system, and those we call the guest OS, the guest operating system. So don't get those confused. The host machine is running virtual machines, and the host machine has an operating system. And the virtual machines, each of the virtual machines has its own operating system called the guest OS. And then finally, we have hypervisor software. And that the hypervisor is the actual software which is creating the computer emulation. That's creating these virtual environments. And the hypervisor is able to manage the communications between these virtual machines and the physical server, the host machine. There are a couple different types of virtualization that you might encounter in the marketplace, and I'll mention three different types in this lecture. The first type of virtualization you might encounter is what we call hardware virtualization. And this is a type of virtualization that you might encounter if you're working with large mainframe systems. In a system that's implemented hardware virtualization, there's an actual physical part of the server which is dedicated to a specific stack. So you might have like a mainframe type system, and that mainframe type system is actually partitioned into, let's say, 100 small physical servers. So this is sort of architecturally designed into the actual mainframe system, where if you looked inside the mainframe, you'd actually see 100 different physical servers, each one of which is allocated to a separate stack. And the idea behind this hardware virtualization is that it can provide very high reliability, resiliency at a hardware level. Of course, you're going to spend a lot of money for this type of resiliency. The second and by far the most common type of virtualization that you will encounter is software virtualization. This is the idea where we can take a physical server and emulate it in a piece of software called the hypervisor. And there's two types of software virtualization that you might encounter. There's type 1 and type 2. A type 1 hypervisor runs on top of the bare metal. So it runs right on the physical server, and it sits between the physical hardware and the operating systems that are running within each virtual machine. Examples of a type 1 hypervisor include VMware ESX, Microsoft Virtual Server, and the Zen hypervisor, which is what Amazon Web Services uses in their EC2 service. The second type of hypervisor is what we call a type 2 hypervisor. And a type 2 hypervisor does not run on the bare metal. It's not installed directly on the physical server. Instead, it's installed on top of the operating system, which is installed on the physical server. Examples of a type 2 hypervisor include Oracle VirtualBox and VMware Fusion. The advantage of a type 2 hypervisor is that you can just run it on your desktop. You can run it on your laptop, and you can emulate different computing environments without having while retaining the ability to use your Microsoft Windows or your Mac or Linux operating system. The Type 1 hypervisor, on the other hand, is generally faster because the Type 1 hypervisor is installed directly on the bare metal. It doesn't have to go through an additional operating system layer. And you can see the difference between the Type 1 and Type 2 hypervisors in these diagrams. The Type 1 hypervisor is on the left. Here you can see the Type 1 hypervisor is installed directly on the hardware. It's installed directly on the server. You can think of a Type 1 hypervisor as almost being like its own type of operating system. The Type 1 hypervisor allows you then to create virtual machines, and each virtual machine has a guest operating system and a set of applications. The Type 2 hypervisor, on the other hand, runs on top of some sort of native operating system. So I have my physical hardware. Maybe this is my laptop. My laptop is running the Mac operating system. And in the Mac operating system, I install the Type 2 hypervisor, which looks like just like any other software application. When I start my Type 2 hypervisor, then I can emulate and create virtual machines, each one of which has its own guest operating system and set of applications. And alongside of those, my host operating system can have its own set of applications. The Type 2 hypervisor oftentimes is used within a development environment where performance isn't really that critical. The Type 1 hypervisor, on the other hand, is oftentimes used in production type environments where performance is a really important characteristic. There's also another type of a way that we can deploy software virtualization. There's what we call full virtualization versus para-virtualization. If we are deploying our software in a hypervisor that implements full virtualization, then the guest operating systems that are running within that hypervisor are not aware that they're being virtualized. In other words, the guest operating system does not need to be patched in any way to run within that environment. The hypervisor can support what's called para-virtualization in an environment where the hypervisor is supporting para-virtualization. In those cases, the guest operating system is patched. It usually has some sort of special kernel modification or drivers, and those drivers provide enhanced performance because the operating system is sort of like designed to be virtualized, and it's aware of the fact that it's being virtualized, and it can take advantage of these special kernel modifications to reap increased performance. The third type of virtualization that you'll encounter in the marketplace, and this is probably the fastest type of virtualization, is what we call OS partitioning. And with OS partitioning, we have generally a single operating system that's running on a physical server, and that single operating system is able to partition out processes and memory and the scheduling of tasks, and it's able to do that in such a way as that it's able to create multiple environments that look like separate operating systems and separate servers. Except in this case, all of the operating system environments are using the same operating system kernel. They're using the same kernel which exists on the host server. So it's the host OS. The most common example of an OS partitioning technology that you'll encounter today is something like Docker. And we'll spend 2 lectures later on this course talking about Docker containers and how they provide OS partitioning. So today, when you're creating applications and you're deploying applications either within your on-premise servers within your organization or on servers out in the cloud, what you'll find is that the server virtualization technology, in particular software virtualization or OS partitioning, the virtualization is now the predominant form of, of infrastructure that you'll encounter. Most servers today are running virtualized workloads. Gartner estimates that 75% of all the workloads, of all the software stacks that are being deployed by enterprises are now virtualized. And we've probably sort of reached sort of peak saturation in the marketplace because it's just sort of like become the de facto way that we deploy our applications. So if somebody tells you they're deploying an application to a server, more than likely that server is actually a virtualized server that's running alongside other virtualized servers on the same physical server. There are other types of virtualized infrastructure that you'll encounter in the marketplace. So not only are we virtualizing our servers, but we're also virtualizing things like our desktops using virtual desktop infrastructure. If you use a computer system in a lab on campus, when you log in, you're actually logging into a virtual desktop. There are storage virtualization solutions that allow you to pool together storage devices from disparate vendors, and storage virtualization will present this sort of pool of storage as being this sort of single storage device. There's also network virtualization, which is becoming very common. Much of the network infrastructure that's running in cloud computing providers is virtualized. We can use technologies like software-defined networking and software-defined infrastructure to replace our traditional network components like physical switches, routers, load balancers, and firewalls.